This is going to be our last presentation today, but I assure you it's going to be a very powerful message from Martin, who has been a friend of the PPI team for many, many years, even before SPS and PPI was actually created. And so it's a pleasure to introduce Martin, particularly with me. Martin and I have had the opportunity to collaborate for several years on certification efforts. As you saw earlier, we travel to many places around the world, dealing with multiple professionals in the industry. And one thing that I think I can say is that it doesn't matter where you go, we have the same problems, okay? The engineering industry, construction industry is the same. So let me introduce Martin formally. I don't want to miss any important details of his bio. And so Martin Fischer is a professor of civil and environmental engineering and, by courtesy, computer science at Stanford University. He is also the director of the Center for Integrated Facility Engineering, CIFE, a senior fellow of the Precourt Institute for Energy, and the coordinator of the Building Energy Efficiency Research at the Precourt Energy Efficiency Center. There are probably many other things about Martin, but I'm just going to let him.
I have the list there.
Let him take us through a very interesting topic this afternoon. Thank you, Martin.
Thanks, Roberto. It reminded me of one of the experiences we had in Stockholm on one of our journeys that led to some variability. I don't know, you probably remember the first time we taught the VDC program at somebody else's place, not at Stanford. And this was a general contractor in Stockholm, and this was March. We arrived late in the evening, and then we crashed from the flight, and then the next morning they said, yeah, you can just walk. It's just like a kilometer, a little more than a kilometer. And we looked outside the hotel. Things looked okay. I mean, there was snow, but it looked okay. So we figured, yeah, that takes about, maybe we should allow 20 minutes or something. So we start walking, and then we come up just like, 100 meters at most to the main road, and we turn left. And then we look at the sidewalk, and we should have had ice skates. I don't know if you remember that. It was just like the whole kilometer was just blank ice. And we were a little bit late. But we arrived. Anyway, so now it has been really amazing to work with the PPI team. And so I would like to talk to you about product design and process, from product design to process design. Actually, I would say from product design in one silo and some kind of process design in the other silo, to concurrent and integrated product and process design. And we saw already examples right from Phil of that in a sort of a little bit different industry, but we saw the importance there of thinking about the products that they need to deliver, and then the process of how, well, we get the order to them and then they get things to us. But also just now, from Juan, we saw at a very detailed level the connection, right, and how improvements really came from using, I guess I'll jump here, at least several of the 5 levers that I'm sure you have seen over the course of today. Adjusting the product design, adjusting process design, thinking through capacity, inventory, variability levers. The message we have is really what we see as a foundation for practice of designing, building, and actually also operating the built environment. Because we find ourselves, I think, at a very special place right now with a tremendous opportunity. And so I agree with Phil that, yes, you don't need just concepts, you need implementation. But we need to have concepts. And I think that's where we need to get better in our industry. It's a bit different maybe in other industries. We now have the opportunity to bring concepts that have been proven, tested, applied in other sectors, in other industries, to our industry. And I'll briefly explain why. So that's really the next practice. So we have, apparently playing the video is slightly more challenging. I just wanted to remind us that we have all experienced the benefits from over the last, say, 2 decades, actually, frankly, even slightly longer than that, but let's just say 2 decades, of using product models and sometimes connected with the schedule, 3D models and 4D models. It's kind of unthinkable to create a design and build something where you don't have at least a good visualization of what we are imagining and what we're going to build, bring the team on the same page, use information that's connected in the 3D model to create the bill of materials, and so on. I hope you don't have projects where you don't do these things anymore. So we have seen the value of product designs. And I, on purpose, picked an old video, but then it became actually difficult to embed in the time I had. This is a snapshot of the 4D model from the Bay Bridge, which I like. So this was done 13, 14 years ago. And it shows, I mean, you can see in the snapshot already, kind of, it shows the construction of the bridge. It shows the fabrication of the bridge segments in China. And it also shows when they're being shipped, et cetera, different stages. So in one picture, you had really a lot of data aggregated, visualized for people to understand. That was just a quick reminder of the value of 3D models that is really kind of unthinkable for us to do projects. More recently, a supermarket chain in Sweden reduced their construction costs by 45%. By getting out of the myth of every project is unique and standardizing the 90% that is actually not unique, and then allow the project team to focus on the things that are truly unique. I think that's an opportunity that I still see many organizations can take. Just as a reminder of the value of these, you could call them product models. That was actually the original word before terms like building information model and so came up. But the thing that has changed in the last few years, is this story here. So I think today, right, this would be kind of weird if you said this to somebody. Like, that was not very data-driven of you. But I think it's not so far in the. I think at Amazon, I don't think that, like, I would imagine that you would say that, right? Yeah, but in our industry, yeah, it's not. I haven't heard it yet. But we are definitely getting there because the ability to collect data on how our work is going has just exploded in the last few years. And I don't see that slowing down. And companies are collecting tremendous amounts of data, which is fantastic. But because we're lacking or we're not using key concepts, process design and process modeling, production modeling, we cannot actually really make great use of this data. So I want to illustrate that. And basically, the message is, yes, use these technologies, take advantage of the data you can collect, but in parallel, upscale the conceptual thinking that you have around production processes and how to connect that with product design. So I'll focus, so I'll give a couple examples to hopefully bring to life what I'm talking about. First example is using the IoT crane hook from Versatile. So you might use it on your projects, where basically the crane hook collects the data, everything the crane is doing. So now you get a second-by-second story for the whole duration of the project, what the crane was doing. Idle, being rigged, loading this kind of, lifting this kind of load, et cetera. So that's quite a lot of data that you're getting. And so this is the first time we were able to work with a company, it was a few years back, where we could see what value can you get from this detailed data. So this is Clock Pacific for the construction of a parking garage near San Jose Airport, about, I think, 1,200 car garage, something like that. And of course, for a precast project, the crane is pretty important in terms of it going well or not. So up to that point, they only had average time. So I didn't have time to have somebody there standing around and log all kind of data. They just looked at the end of the day, we put 45 pieces of precast in place. We worked 7.8 hours. Okay, so many pieces per hour. or so much time per piece. That's the data they had. Like, I think pretty much everybody that we have found in the industry. But now they had this technology that gave them data about every step, every cycle, every component, right? And we're then curious, can you create a better life? So sheets and sheets and sheets of data, right? The situation we wanted to help improve, or see if we could improve at the data, is can you make a better prediction for tomorrow? Because if you're the manager on that project, you live and die by how well, economically, not otherwise, how well your prediction is for how many pieces you can install tomorrow. If you order too few, because the yard is in Sacramento, the site is here in San Jose, so stuff they have to call the afternoon before, hey, send these pieces, these beams, these double Ts, these columns, and so on. And because you have to install them straight from the truck. You don't have budget or space to unload them, find them again, and put them back up. So the inventory is at the yard, and then you have to just install them. If you're under, obviously you pay for the capacity anyway. If you don't order enough pieces, if you order too many pieces, then you pay overtime. On average, Clock Pacific is a very good company. They were 2 hours off per day. So you can see it adds up over the duration of a project. So the question was, could we, by using the detailed data, help them make a better prediction? So here's basically what they were using, aggregate activity durations, so summary activity durations. And so basically we studied the difference in how many pieces you would order. If you used the aggregate data, it takes 24.5 minutes per piece, or whatever the number might be, versus per type of part. Right now we have the data. We can say beams take this long, and this is the variability. Double T's take this long, and so on. Or if you go to every step of the process for every component. So for that, we had to actually develop a tool, a next-day look-ahead planning tool that was fully automated, because you can't possibly, that afternoon, sift through all of the data and make sense of it manually. And then, so I know this looks a little crazy at first, but then we made the comparison. So in gray, you see, let's see, maybe I'll have to do it like this. In gray, yeah, it doesn't show up, okay. All right, the black line is if you ordered exactly enough parts for the day, then a dot, which represents basically, if it's above the line, it means you had to work overtime. If it's under the line, you waste the capacity. So basically, from left to right, I guess I should have started there, it's the days. And then each dot represents how many pieces grayed out, how many pieces they ordered. And you can see that on some days they were quite good. On many days, they were quite far from the perfect order. And then you saw the color scheme here. Yeah, no, it didn't translate well, I'm sorry. Oops, that was the wrong button, obviously. Okay, yeah, sorry. Anyway, the colored lines are basically leveraging the detailed data. And you can see that on pretty much most of the days, the detailed data allows you to get closer to the perfect order. Not perfect, but in summary, we could show that the detailed data would allow us to reduce the forecast error by half. And we gave somebody 2 hours each day to do something else, because we had to automate the look-ahead planning. So this is kind of an illustration of the value, one example of the value you can get when you actually leverage the detailed data. But I think the actual value is much greater than, of course, this is, I think, pretty nice to have. But it also shows that we do need to develop some new tools to actually use all of the data that we are collecting. We continue this kind of line of collaboration with industry. We're currently working with HDCC on the construction of these kinds of towers in Honolulu, where we use computer vision methods to find how long different activities take, so we can then connect them into a production model. And this is kind of the key point I want to make, right? Same thing for the Clock Pacific. The schedule was at kind of a summary level. And now you have extremely detailed data. The two no longer connect. Before, the average data was fine because that was the level of detail you had in your schedule. But now you have a lot more detail of what actually goes on, and you have only some summary schedule. So if you want to make improvement, because you now have the possibility for this feedback loop, you can't. You're back to stories and anecdotes. And there's the same here, where the schedule is rebar in zone A. Yeah, but the story, if you want to improve it, is you have to look at a lot more detail. But now you can, well, if you're successful in this case with the computer vision, but we also have data from other sensors. So for that, we need to develop, and sorry that this picture is so faint, I don't know what happened. But we're basically using the PSO tool from PPI and SPS that allows us to really model how the process happens and then connect the detailed data to it so that we end up with a process that model that we can look at and that we can compute. And this is really where we have to go. Because we've seen the benefit of having a product model, a building model, or whatever you want to call it, that we can look at in 3D or 4D, and the data connected to it. But we don't have the same thing for our production processes, at least not in widespread use. And you might have said, yeah, up to recently, yeah, Martin, that's kind of a nice theory. How am I going to actually implement that? But today, you can implement it. Actually, you have to implement it. Because if you don't implement this much more detailed production process models for your engineering and management work, and for the work offsite and onsite, you will not be able to take advantage of the detailed data you can collect. And I would not want to have to compete with somebody that is able to do that. It's just maybe what I would say. So we also, the same applies for offsite factories. We've been able to do a study with a bathroom manufacturer thanks to Bochen. So you can ask Bochen questions about it. But basically, this is this was the plan for the project. They wanted to produce all the bathroom parts before they delivered the first to the site. We think it's a little bit crazy, but they just didn't want to get a call from the site saying, hey, I need that part and not have it. So in reality, so then this basically they built up the inventory and then they built it down. The reality actually looked a little bit different, but the conceptual idea was what was shown on the previous slide. But in reality, this is how the demand from the site actually happened. So quite a bit of variability. But still, you can imagine the inventory cost was really very significant in this case. And again, by building a production simulation model that we could validate with the actual data, we could then make, I think, a believable prediction that you could have reduced the inventory cost by 80% and still met the delivery requirements from the site. So not bad, as we say in my native Switzerland. But because, yes, it can be challenging to connect the offsite and onsite. Although I think, again, with the transparency, the kind of transparency visibility that Phil was talking about, we can do much better. And we definitely, you could see the variability that actually happened in that situation on that one project. But we can be much smarter about how we actually handle it, manage it, how we can reduce it, and then how we can actually manage it by getting a bit out of our silos. So basically, the key message, we need to create a digital twin, or whatever your favorite term is, digital replica or something, of our production processes. And by that, I mean something we can look at together, because we have to be on the same page as people with different functions and roles. It's super important. And we have to be able to run simulations, compute things, connect with real data, et cetera. So I think that's the task ahead for us. That's what we need to do. If we do so, we will be able to leverage all 5 levers. If we don't, then the levers will be in their silos, and their effect will be dramatically less than what it could actually be. Thank you.
Any question for Martin? Anybody? Please raise your hand so I can approach where you are.
Was that just preaching to the choir and everybody saying, yeah, we already got that? Or is anybody going to take action?
Where did you get your t-shirt?
Amazon. No, actually, I don't know where I got it. It showed up in my Facebook feed, and then I'm actually not sure who actually delivered it. I'm sorry. I would have to look at my email. Yeah.
Thanks again for the presentation. It's always entertaining. In the crane example using the IoT sensor, how did you take into account the variability that the IoT sensor wasn't measuring? Such as, I don't know whether it did wind speed, you can't lift at a certain wind speed, stick operator, equipment breakdown, those kind of elements that may not have been associated with the IoT sensor, and factored that into the variability.
Yeah. So that was so we used actually the data from that project in my class, my graduate class called Managing Fabrication and Construction today as a possible class project. And we had quite a few students analyzing the data in all kinds of ways, which was cool. And they had just the presentations this morning. That's why I had to be there and not here. And that was exactly so they asked actually the people from Versatile were also listening in. They supported us, super helpful. And they actually asked exactly this question. They said, what could we do? What else would make it easier? And then the first answer from the students was, yes, we can pull. So what we had to do is we had to create a data mashup because we had to get weather data for, the location, superimpose it, connect it, and start to make sense of it. It would be super helpful if you already could collect some of this data, like wind speed, precipitation, humidity, things like that, because, and then there was generally the insight that we keep running into. As much data as we can now collect, it's still not enough. So we gain tremendously interesting insights. For example, they found that they looked at the cycle times in the week before holidays, and they found that let's see, what did they find? Yeah, they found actually the Monday before, so the 5 days before a holiday, they were quite faster than typical, and then the 4 days before the holiday were actually quite a bit slower. So, but now you have data, right? Because you might believe all kinds of, everybody might have their own story, back to this point, right? But now you have data on some of the things. But then you wonder, right? You need to connect it with the schedule. What were we actually trying to do? Were the load types different? Because we were approaching a holiday, maybe things, So you need to connect a lot of data. That's what we keep seeing. Yeah. There's definitely, I think, an opportunity there for somebody in the consulting and startup world, tech world.
I do have a question for you, Martin, but before I do that, I want to ask any other question coming from the audience? Anyone? 1, 2, 3. So, Martin, I think what you just told us is that if we don't have in our organizations a production system perspective and we don't focus on the production system, do we have a choice not doing it?
You always have a choice. But if you want to attract great people and be competitive in a few years, I don't think you have a choice. Would be my take.
I think we see the same thing because with all these data and the production system, and the data is actually from the production system. It's not from the schedule.
Yeah.
Right? So we need to move from the schedule to the production system.
And to your point, right, without what the students also saw is if you don't have a production system, if you don't have that map, then you don't actually know what data you really must have and what data you must really connect. And then we're back in the world of just in case, let's get all of this. Then we're back in the world of drawings. Let's just make a whole bunch of drawings because somebody might need them. Or in case there's an issue, we can say, well, no, it was on the drawing, right? But not productive.
Bruce?
Sorry, you're getting hit from over here all the time. Everyone's special. So my project's completely different to every other project that's ever happened before, and nothing's the same, right? That's not true, but
no.
So the examples there were sort of quite modular type items, or multiple floors of a building, for example. How do you take that same principle and apply it to these more less repeatable type projects?
Mm-hmm. Yeah, I think so of course we should think about the product and see what can we, I really don't care that much for that word, standardize. So, but for lack of a immediately better word that comes to mind, modularize, systematize. Systematize might be better. But I think there is actually more opportunity to sort of systematize our organization and processes. And so I should have maybe told the story that I briefly showed just to highlight the value of a digital model connected with information, a 3D model in the supermarket chain in Sweden. Of course, they did more than that. And they really first standardized as much as they could the decision-making processes for each of the different stores, because it was exactly the same story, right? How do you want to compare a store in downtown Stockholm with one at the outskirts in the north of Sweden in a little town of Luleå? Like, it's a totally different story, right? But the reality is actually about 90% is the same from a decision-making process and an information flow perspective. So they organized, they sort of standardized, systematized that first, and then through that they were actually then able to recognize what can they modularize in terms of the physical product. And I think that's still an opportunity we have, even if we build extremely unique things, because you're not reinventing everything from scratch every single time. Occasionally it happens, I understand, but
no, we're not.
Yeah, general. Well, yes, you are, but you don't have to, I would say. I think it's rare that you would have to.
We like being special. Everything's special.
Yeah. No, I know. And I know.
There's another question.
Yeah, okay.
Just add on to what Martin's saying. I think one of the secrets that we use that I'll put out there is, for something to think about, Bruce, is to get to the lowest common denominator. Pulling, welding, fixing, rigging. And so the lowest common denominator, right, is the lowest common denominator. And I think that's where you were headed, Martin, right?
Yeah.
So,
when I'm feeling sarcastic, then I say, well, then if everything is unique and you make everything new from scratch, then doesn't matter. You could hire anybody. You don't need experience.
and you wouldn't have trades and crafts.
I mean, which I understand is an extremely sarcastic comment, and not true, but obviously there's something there that is common, right?
Engineering designations, craft designations, right?
Yeah.
Right?
Any other question, comment? I do have one, and it's a simple one, because the concept of a production system typically might get associated with something that is repeated multiple times, right? Something that produces a lot of things off. But, which is right, but what if we have a one-off situation? So we have applied these same structures and frameworks when we have a one-off situation. And it's even much more powerful because we have only one chance to get it right. And we still have a production system, right? If we have one chance to get it right, what are the odds that we can get it right, right? And so it's not just related to repetition, although that's probably where we're going to see a lot of value. Okay? So we have map production systems that are both types, if that makes sense.
Thanks.
Okay, so thank you, Martin. Appreciate it.
Yeah, thanks for having me.